welcome back to another installment of Math with Medina. Today we're going to look at solving inequalities using multiplication or division. Throughout the video I'm going to reference the last couple videos we've had, the one on the introduction to inequalities as well as the video on adding and subtracting inequalities. So it's really important that as we're working through this that you really focus on the details of what you're doing. So before we go on, I just want to reinforce this idea of the comparison between an inequality and an equation. Now notice it says you do not need to copy this. I just really want you to listen as I go through a quick review, just like I did in class the other day. So as we look at this, remember that with an equation and an inequality, they each have two sides. So we will continue to discuss things as a left side and a right side because it's really important that we keep in mind, particularly with inequalities, that our variable as it's on the left side helps us to dictate what our graphs are going to look like, how we shade our solution sets, as well as ensuring that we are in fact identifying the solution correctly. So remember that the difference, the really big difference, is just the signage. That when we look at an equation, there's an equal sign and there's a does not equal sign. Where with an inequality, there's greater than, or equal to, less than, or equal to. And remember, each of those are discussing that idea that an inequality is two things that are not equal typically. So we're looking at comparing the first quantity or first value and the second value. And the other major difference is solutions. It's really important as we think about the solutions of it in the equation that we remember there's three different types. That we can just solve the equation and get x equals something or y equals something. But then at the same time we can end up with these two special circumstances here at the bottom of all real solutions or no real solutions. And remember, those happen when our variable disappears and we're left with one number is equal to another. And either you end up with a true statement, which is all real solutions, or with a false statement, which means there's no number in the world that could make that statement a true fact. And when it comes to inequalities, keep in mind, we're looking for a solution set. So we're looking for solutions or numbers that make this statement true. That's why we'll make a statement that it's going to be any number greater than or less than, because any number that fits into that description is a solution. So we can't be specific with one number in any way. So keep that in mind as we're moving forward. All right, so I need to introduce the first of two major rules today with multiplying. And when we're multiplying a positive and an inequality, for example, if I said times 3 on both sides of this inequality, well, 4 times 3 would be 12, and 5 times 3 would be 15. So I'm going to ask myself the question, is this inequality true? And I would say, yeah, that's true. And so if it's true, then it would be a statement that is in fact 12 is less than 15. But now if we look on the other side of things, if I were to multiply, let's say, by a negative 3, well, negative 3 times 4 would give us, think about it for a second, that's right, negative 12. And 5 times negative 3 would give us negative 15. Now, if I ask the same question about the inequality, is this inequality true that negative 12 is less than 15? I would say no, it's not. Because it isn't true that negative 12 is less than 15. Well, if that's the case, then what I actually would need to do here is I would need to say negative 12 is greater than negative 15. And what I want to point out is if you look from this inequality sign to this one, we actually flipped it around. So if we're going to make a rule here that we're going to use moving forward, it would be this. Let me go ahead and please copy this down. That whenever you multiply by a negative, you must flip your inequality sign to face the opposite direction. Now, I want to stress when we say multiply by a negative, that's when we use that multiplication property of inequality where we multiply by a negative on both sides of our inequality sign. Okay, so after you finish copying that down, let's go on and look at a couple practice problems here. All right, and in an effort to keep us focused on one practice problem at a time, I'm going to go ahead and put that revealer up again. So we'll just look at this left-hand inequality. So our inequality reads 4 is less than or equal to x divided by 2. Now our goal, just like it is on an equation, is to isolate the variable so we can make our final statement about our solution set. So I see that x is being divided, so I'm going to multiply both sides by 2. So I would end up with 8 is less than or equal to x. But remember, I stressed that in class that you must have x on the left-hand side. So we're going to actually flip the x and the 8 around, and my alligator continues to eat the x just like it did up above. So in this case then, my solution is x is greater than or equal to 8. And again, we need to make sure that we put a description of our solution. So solution is any number greater than or equal to 8. So I can see down here at the number line, I want to graph my solution. So I start out and say, okay, I'm going to go to 8 and I'm going to put a closed circle because of the equal to. And then greater than tells me to shade to the right. So I'm going to shade to the right. And when I look to prove this, I look up and I remember that the problem involves me dividing by 2. So I really want, as I write down this original problem here, 4 is less than or equal to x over 2, I want to pick a value to check this that is someone that's divisible by 2. So I'm going to go ahead and try 10. So I plug that in, 10, and then I rewrite the rest of my inequality. 4 is less than or equal to 10 divided by 2. And then as we evaluate that, 4 is less than or equal to, and 10 divided by 2 would be 5. And I say, sure enough, that's true, which tells me that my solution set is shaded in the right direction on my graph, and it's identified correctly. Now remember, I stressed that you should never, ever, ever pick that point that you start your graph at, because you'll always prove yourself correct in an equal to problem, but it doesn't necessarily tell you that you did shade correctly to the left or correctly to the right. All right, let's look at another problem here. And this next problem, we have negative 7 is less than x divided by negative 3. So this time around, I see the x is being divided by negative 3, so I'm going to multiply by negative 3 on both sides. And on the left-hand side of things, I'm left with a positive 21. And on the right-hand side of things, I'm left with just an x. Now, I just rewrote my inequality sign, but I have to stop myself because time out. I just multiplied by a negative. So I can see I already just made a mistake. And that's one of those times it's really important. Before I write it, I ask myself this question. Did I multiply or divide by a negative? And we'll get into dividing on the next slides. But did I multiply by a negative? Yes, I did. So in this case, it's super important that we flip our inequality sign. Notice I didn't flip sides of my values. I just noticed very clearly that I multiplied both sides by a negative, so I need to make sure I flip that sign. Now, just like we did on the problem before, I can see the variables on a side that I don't want it on. So I'm going to switch the x and switch the 21, but I need to make sure the alligator or the inequality sign is opening up to the side of the 21. So I need to make sure that that alligator mouth is continuing to eat that 21. And if I were going to describe my solution in this set, I can see that the solution is any number less than 21. So we're going to come back here and we're going to again graph. So we go to 21 this time, but this time around, as I go to 21, I look and see, hey, it's not equal to, so it's important I make a very distinct open circle. And then if I think about myself standing on it like a stick figure, I say, okay, which way would I want to walk in order to be less than 21? So I'm going to go ahead and I'm going to walk to the left side and shade that. Now, just like before, I look up there and I see, okay, it's divisible by 3. So it's important that as we rewrite our original inequality, negative 7 is less than x divided by negative 3. I need to find a value in this number line that is divisible by 3. So I look and 18 should stand out to me. So I'm going to go ahead and put in positive 18 to that original inequality. So I have negative 7 is less than 18 divided by negative 3. Negative 7 is less than, and 18 divided by negative 3 is negative 6. And so then I remember on a proof, I have to ask myself, is it true? Is it true that negative 7 is less than negative 6? And hopefully you'll say, yeah, totally is true. So I'll say, okay, I know I did it correctly. Now, one of the areas I really want to emphasize in this rule, especially now that we're going to introduce division on the second half of this lesson, is this part right here. Because I am dividing the 18 by negative 3, but notice my inequality sign didn't flip, because when I'm proving something, all I'm doing is simplifying the first expression and then the second expression. Alright, so that's the rule of multiplication. The really big take home of it was what we talked about up here. that if you multiply it by a negative on the left and on the right, it's really important that we flip that inequality sign. Okay, so now let's move on to division and take a look at that. So now we're going to talk about what happens if you divide the inequality by a positive, and then we're going to look again at what happens if I divide it by a negative. So this time around, let's divide it by 3 on both sides. And so what I'm left with on the left-hand side is 4 is less than 5. And then I ask myself, is that true? And I would say, sure is. So I know that that's a valid statement and a valid process. And notice my inequality stays the same, nothing changes. Now, on the right-hand side of things here, if I divide by a negative 3, same situation. I come through, 12 divided by negative 3 is negative 4, 5 divided by negative 3 is negative 5, and then if I write in that inequality and ask the very same question, is negative 4 less than negative 5, I stop and say, no way, it's totally bigger. Then in that case, it's important we identify that the rule in this case, I need to flip the inequality sign whenever I divide by a negative. So just like when we multiplied by a negative on both sides, if you ever divide by a negative on both sides, it's super important that we pay attention to that inequality sign and that I end up flipping it as I go through my steps. So it's important, please take a second, copy down this rule because we're going to go through and look at this on a couple practice problems. And the rule being, whenever you divide by a negative on an inequality, you must flip the inequality sign to face the opposite direction. So now let's move on and look at a couple problems here. So the first inequality we're going to look at is 3x is less than negative 12. And again, I'm going to put up the revealer for the first one to keep your focus on this first problem. So we look at this, 3x is less than negative 12. I say, all right, I know how to do this if this was an equation. Same situation, I'm going to divide by 3 on both sides. And this time around, I'm left with x is less than, and negative 12 divided by 3 is negative 4. Now, even though I divided by a negative and a positive here, notice that my inequality sign didn't flip because the division that I did with that division property of inequalities, I did it on both sides. So I can read my inequality now tells me that my solution is going to be any number less than negative 4. So on my number line down here, I'm going to go down to negative 4, and I look and see, nope, it's not equal to, so that puts an open circle, and less than, remember, less is left, so from negative 4, I'm going to shade to the left-hand side, and then I write down my original inequality, 3x is less than negative 12, and then I'm going to come back in here, and I'm going to put in a value for x, so, and I look and think, oh, it's multiplication, so it doesn't matter what value I pick. So let's just pick the one that stands out to me as 7. So I put in negative 7. And then I come back here and I evaluate the left-hand side. 3 times negative 7 is negative 21. The right-hand side, negative 12. And I rewrite my inequality sign. And then remember, ask myself the question, is this true? Negative 21 is less than negative 12. And we say, sure is. So then we go on to our next problem. And we look, all right, so now I have a negative coefficient. So I'm going to start out by dividing by negative 4 on both sides. And as I come through, I want to simplify each expression. So I have x, negative 24 divided by negative 4 would give me a positive 6. And this is one of those points, it's really important that you kind of pump the brakes and slow down and say, wait a second, I just heard myself say divide by a negative. Okay, it's an inequality. You need to make sure that I flip that inequality sign. So notice we divided by a negative, we flipped it. And we box our simplified inequality. And remember, part of communicating our solution is explaining what that means. And that just tells us that the solution is any number greater than or equal to 6. So we're going to go to 6 on our number line. And just like we did before, at 6 we're going to put a closed circle. And the reason why is because it's equal to. And then because it's greater, we're going to shade to the right. So I'm going to shade to this right-hand side. And then I look back to my original inequality. I write it down. Negative 4 is x is less than or equal to negative 24. And it's multiplication, so again, it doesn't matter. So this time around, the one that jumps out to me is the 10. So I'm going to put the 10 into this original inequality in place of my x. So I have negative 4 times 10 is less than or equal to negative 24. And this is, again, really important we understand that relationship of negatives. Even though 40 looks like it would be bigger, remember that negative 40 is actually further away from 0, so it's smaller than negative 24. So I say, sure enough, got that one correct. So that reminds us that we shaded in the right direction. So I want to wrap up here with 2 slides that are just reminder slides. I would ask you to copy them down, and it's really important that you kind of have these ideas in your head as you're working through these problems. The first slide is this one, the reminder that when you're checking your solution on an inequality, you must pick a value and substitute it into, that's right, that original inequality. Make sure you're not substituting it into your final solution. So for like the problems we just did, it's really important that you don't substitute it here into x is less than negative 4, but that instead you substitute it into here, and we substitute into that original inequality. All right, so the final big reminder is this slide here. And what this really is just like the title says. It's really your 4 steps to inequality. And the first one in your 4 steps to solving an inequality is simply this. To remember to follow all of the same rules as equations in inverse operations to keep it balanced on both sides. So if you add on one side, you add the same thing on the other. Divide on one side, divide the same thing on the other. But we did just add in a new kind of wrinkle or change. And that's this, that you only flip the inequality sign if you multiply or divide by a negative. But that it's super important that you do flip it. And remember, on part 2 is that when you get your solution, that when you're graphing it, it's an open circle if it's only greater than or less than, and if it's closed at if it includes equal to. And which direction do I shade? The final second to last thing, and that's this. You shade to the left if it's less, and you shade to the right if it's greater. One of the great ways I think to remember that is that less and left start with the same letter. So there's a little bit of alliteration there. And the last part of things on number 4 is just making sure that when you check your solution that you pick a point from the shaded area. Do not pick the point that you start at. All right, so I look forward to working with you in class on some of these, and I will be back with you again very, very soon.